So we left the previous lecture with 4 services which look like this. And now we need to decide what kind of messaging is the right one between each of them. Let's begin with the receiver. The receiver, as its name implies, receives the messages from the IoT devices. In this case, the messaging method is actually dictated by the way the various devices send their messages. To find out how they do it, we will go back to the client. After a few phone calls, she comes back to us with the answer. The devices communicate via HTTP using the post verb to send the update. Well, that's great. It means our receiver just became a standard run-of-the-mill web API application with REST API as its interface. Great. Let's move on to the handler. Now, here things begin to get a little bit complicated. As you probably remember, the handler's role is to validate and parse the messages received by the receiver. Its only reason for existence is to offload the tasks from the receiver, which should focus on receiving the messages and releasing the requests. After the handler handles the message, it should store it in the data store for later use. Now, what is the best messaging method between the receiver and the handler? Well, it looks like the best mechanism here is queue. We obviously want the messages to be processed in the order they were received, which is a classic feature of a queue, and we like the reliability and scaling such a mechanism offers. If we would use REST API between the receiver and the handler, the receiver will have a lot of work to do, since it will wait for each request to the handler until it is done, and will have to handle errors and glitches. This will hurt the performance, which is so important for the receiver. Using queue, we basically have a fire and forget mechanism. The receiver puts the message in the queue and forgets about it. This is exactly what we want in this case. Great, so we have REST API for the receiver and queue for the handler. What about info? Well, that's an easy one. Let's see. Who is going to access info? The answer is, of course, end users. How are they going to do that? Well, obviously, via a web browser. How web browsers access servers? Of course, using the HTTP protocol. And the de facto standard for accessing HTTP servers today is via REST API. So, the info will implement REST API similar to the receivers. Last but not least, the logging service. Remember, we need the logs produced by other services to be sent to the logging service for aggregation. How can we do that? Well, instinctively, we might think the logging service should expose REST API, so the other services can simply access it, sending it the log records. But that's not a good idea. Logs tend to be quite massive, and we can expect the various services to produce a huge number of log records every hour. Now, if for every such a record the services will issue a REST API call, this will hurt the performance badly. We need a solution that will enable us to send large amount of records to the logging service without impacting the performance. Now, one of the common solutions to this problem is using files. In this solution, the various services write the log records to a file, and the logging service polls these files and aggregates their contents. So this is a very popular solution, but it has 2 major problems. One, it won't work in the cloud environment. This course is not about cloud applications, but it's still important to be aware of what's possible and not possible in the cloud. And writing to files in a cloud application is a big no-no. The second problem is that files have the tendency to get locked, to be scanned and removed by antivirus software, or just simply be deleted by careless system admins. In short, file is a highly uncontrolled resource which should better be avoided. Okay, so what's left? There are actually 2 options left. First, write the logs to a database and let the logging service query the database and handle the log records. Second option, use queue. The various services will add the records to the queue and the logging service will pull the records from the queue and handle them. Which one is better? Well, in this case, my recommendation will be to use the queue. The reason is that using database in this case is actually forcing it to behave like a queue. The database is only a temporary storage for the records, and every record that will be retrieved will have to be deleted immediately, just like with queue. So instead of reinventing the wheel, let's just use the queue mechanism and get the most effective messaging. So here we are. We have defined the various messaging mechanisms of the system, and we now have a full picture of the system's architecture. We mapped the components and reached the conclusion that we need 4 of them. We decided what are the messaging methods between these services, and we now understand what are the decision factors for each of the messaging mechanisms. We can now move on to the components drill down. But before we do that, a word of warning. Note that before recommending a client to use queue, you have to make sure the client's IT knows how to set up, use, and maintain the queue engine. If the IT has no idea how to use it, then it might be a good idea to go for a less elegant solution, but one that has more chance to succeed. Okay, we are done. Let's drill down into the first service, the logging service.